Requesting connection. Established. Encrypted. We're live. The show you've been asking for. Advice, technology, and community. Linux first, all others second. This is Ask Noah.
Live from Multispeed Technologies, the Ask Noah Show starts right now. This is the show where we came to do all the things on Linux they said couldn't be done and take your questions on how to do the same. The phone lines are open this hour. To be a part of the program, it is a free call. 1-855-450-NOAH. It's 1-855-450-6624 or send an email to live@asknoahshow.com. My name is Noah Chalai. I am your host. Delighted to be here with you this hour as another episode of the Ask Noah Show kicks off. So picture this. You're a cybersecurity expert named Jake Williams. You are at an instructional teaching event where you're giving demonstrations and instruction to future cybersecurity experts, and you wake up in your hotel room and you open your laptop and check your email and check Twitter and check the various social media sites, and you find on Twitter that you've been cast into the middle of a debacle. And that debacle is that a group known as shadow brokers have stolen a bunch of tools from the NSA. Now, you might be thinking to yourself, why, as a security specialist or as a cybersecurity specialist, would you care that a group stole a bunch of tools from the NSA? Well, the reason is Jake Williams, in fact, used to work for the NSA as part of the security agents hacking group called the Tailor Access Operations, or TAO, essentially a group of the NSA that specializes in breaking into other people's computers. Now, the NSA would tell you that the purpose of this group is, of course, to prevent terrorism, and that they go out of their way to try to find other countries and other entities that mean to do the U.S. harm. I'll leave that to you to see if you believe that or not. As you might imagine, Mr. Williams didn't really advertise the fact that he had previously worked for the NSA. He certainly didn't advertise the fact that he had knowledge of these tools that the NSA were using, because obviously the public isn't supposed to know that these tools exist. The hackers responded by dropping very intense technical details and made it very clear to him that they had access to highly classified hacking operations that he himself had participated in. And obviously that shook him up quite a bit. A quote from his blog: "They had operational insights even most of my fellow operators at the TAO did not have," said Mr. Williams. "Now, with Rendition InfoSec, a cybersecurity firm that he founded, I felt like I'd been kicked in the gut. Whoever wrote this was either a well-placed insider or had stolen a lot of operational data." So this group, shadow brokers, took these tools from the NSA. Now, they stole a particular tool called Eternal Blue back in 2017. And they leaked it out onto the internet. And so hacktivists, and if you're not familiar with what a hacktivist is, it's essentially somebody who goes out looking to break into computer systems for the purpose of making a political statement. They released this tool called Eternal Blue to hacktivists who have now used it to infiltrate the city of Baltimore, and they've been struggling this for the last 3 weeks in a cyber attack by digital extortionists. They've frozen hundreds of thousands of computers, they've shut down email, they've disrupted real estate deals, they've disrupted water bills, health alerts. A bunch of services in the city of Baltimore are now face up, courtesy of the NSA. Yeah, that's right, I said the NSA. I get that it is a hacktivist group that is doing this, but the reality is these tools would not even exist were it not for the NSA to begin with. Quote, "A key component of the malware that cybercriminals used was paid for by the tax-paying citizens at," you guessed it, the National Security Agency. And that, of course, is referencing to the 2017 theft of Eternal Blue that was stolen by the group Shadow Brokers. According to data, there are currently almost 1 million machines in the wild using obsolete Samba version 1 protocol exposing the port to the public internet. And that's effectively how this particular tool infiltrates your machine. So a couple of lessons there. First things first. Don't expose Samba to the internet. It's not really a protocol that's designed to be accessed over the internet. It should be in a closed network. If you have a Samba share, if you have a Windows file share enabled, you should have that shut off to the public internet. And if you need to access it remotely, you should be using VPN technologies. If you need some help on how to do that, check or head over to Mindrip Media's YouTube channel, youtube.com/MindripMedia, and check out our WireGuard tutorial. We'll walk you through it step by step. Second thing, make sure that anything you do have that is on the public internet, for goodness sakes, make sure anything you have facing the public internet is up to date. I mean, my gosh, 2019 is not the time to be putting servers on the internet that have Samba version 1. And I got news for you, because there's some of you out there that are saying to yourselves, well, that's probably other countries. It's probably, Africa and Somalia and some of the countries that, aren't maybe as developed as some place like the United States is. And so maybe they're the ones that have these outdated systems. No, in fact, the most common country found with this Samba port exposed is the United States. So there's that, as the kids say, in 2019. Keep your systems up to date. But then the third thing is this. How long is it going to take? How long is it going to take, and how many people have to be hurt before we as stewards of the technology space take a stand and say we don't want to be spied on by our own government? And look, I understand that there is a group, not an insignificant group of you that listen to the show from outside the United States. And so you're probably saying to yourself, or at least thinking to yourself, I don't really care what the policy of the United States is. I don't have a lot of input on the policy of the United States. And it's something that doesn't really affect me because I don't live in the United States. And to you, I want to say that you're wrong. It does affect you. Because the United States has such a wide reach that apparently, when we decide to swipe our hand and say this particular hardware company is going away, all of a sudden that hardware company goes away. It doesn't matter where the hardware company is based. Doesn't matter what the hardware company thinks. Doesn't matter what the consumers of the hardware company want. What the United States wants, the United States gets. And if you're one of the people that live inside of the United States and you download this program every week, then I challenge you to look into your elected representatives, and I challenge you to do something about it. We get the government that we vote in. And this has gone on for too long, and it's gone too far. And I thought, for a brief moment, I kind of thought, back when the Snowden reports came out, I thought maybe this is the thing that wakes Americans up. Maybe this is the one time where average people are going to start caring about their privacy, where average people are going to start saying to themselves, it's not good enough to say, I don't have something to hide. Encryption by default, privacy by default, warrants first, everything else second. For a brief moment, I thought we might get there. And then Snowden moved to Russia, and then everything basically went back to how it was before. And nobody really cares about privacy. People care about convenience. And people care about being hip and lazy, really, is what it amounts to. It doesn't take a lot to start to invest in your privacy. And the folks at Proton Mail know that, and that's why they've developed a product around it. And the folks that make alternative operating systems for your Android-based smartphone, they know that, and that's why they have the amount of success that they do. Because they understand that there are a certain amount of people out there that do take their privacy seriously. And I guess to try to put a positive spin on it, or to look at the positive side of the flame, as it were, I do meet more people now that are cognizant of their privacy. I meet a lot of people that don't exist on one social network or another because of a particular privacy concern. I know certain people don't install particular apps because they're concerned of a privacy concern. When the story came out about Alexa spying on your home, and we didn't spend a lot of time on it on Ask Noah, because frankly, anybody that listens to this show probably already knows that I don't have a lot of sympathy for anybody that puts an Amazon cloud device in their house and then says, oh my gosh, Amazon was listening to it. Shocking. But when that story came out, you had a couple people that got rid of their Amazon lady tubes and moved on to something else. Maybe it's more secure, maybe it isn't. But I hope that as we watch Baltimore struggle, a struggle that would probably not exist were it not for a tool created by the NSA. Maybe it would. Maybe the attackers could have come up with something else. I mean, let's face it, ransomware isn't exactly difficult to write. But I hope that we can take that as another example and we can try to begin to move forward and say, we want something different. But this is a fascinating situation. It's a fascinating story to Baltimore. It's a fascinating story of how the tools came into existence. It's fascinating, frankly, the response of the federal government. The NSA really doesn't own any of this. They're like, well, we created those tools to spy on other governments and maybe some Americans every once in a while, and we don't really like competition, and this guy came in, and this group is giving competition. They took our tools. Wasn't designed for Baltimore. We didn't design it for Baltimore. We designed it for other countries, and, Americans that didn't know we were spying on them. Somebody took it and used it in Baltimore. We didn't intend that. And that kind of attitude is pretty frustrating. So we're going to continue to watch the situation. We'll continue to watch it unfold. But if you're one of those people that, as I imagine most of you are, that have some influence in those around you come to you asking you for technical advice, asking you for guidance on which technology to purchase and what is valuable in technology, I would just invite you to take an extra moment and give some consideration to the privacy aspect and recommend that going forward, and maybe try to draw some general attention to these kinds of things. We have a bunch of articles linked for you in the show notes. Obviously, you could go down a very deep rabbit hole digging into the technical specifications and the timeline that has laid out over this. It's actually pretty fascinating, and we'll have all those linked for you at podcast.asknoahshow.com. If you'd like to, you're more than welcome to head over there and read them for yourselves, share them on social media, so on and so forth. Of course, you're also welcome to link them to this episode, and then they can hear it for themselves. Again, open phone lines this hour, 855-450-NOAH. It's 855-450-6624. Email live@asknoahshow.com. Rock 0.1 has been released. Now, this is a really cool project. Rock provides a C API for real-time audio transport over IP. So audio over IP is something that has fascinated me since I started looking into launching a radio show. When we first started looking at launching Ask Noah, I looked at all the lessons I'd taken from the broadcasting I'd done in the past, and I said, what do I like, what do I don't like? And one of the things that I figured out and I arrived at pretty quickly is that I didn't like the way that we handled audio, because in most podcasting setups and most broadcast setups, you're using analog audio because it's inexpensive, it's easy, it's cheap, it's just a go-to. But it's really inferior. Consider a Skype call, for example. You have a guest and they are 2,500 miles away. They have a microphone. A microphone is an analog device. I speak, I move airwaves affect, depending on the design of the microphone, affect a microphone in a given way, and it produces an electrical signal. Now, that electrical signal is an analog signal, of course, but as soon as it hits a device that converts it into, that has a USB converter into it, it's converting that audio from analog to digital, and then it's stored as ones and zeros. Now, the great thing about digital audio is once we have digitized a voice, it's ones and zeros, and we can send those ones and zeros as many different times to as many different machines all over the internet. We can do all sorts of processing to it. We can change the levels of it. I mean, we can do everything we want to it and never, ever, ever lose one iota of quality. So that's great. The downside is we don't ever take advantage of that hardly. Audio comes in as analog audio, we convert it to ones and zeros. You'd think that's what it would stay, since the end delivery mechanism, if you're streaming us on AskNoahShow.com, is ones and zeros. If you're downloading us on your favorite podcast app, is ones and zeros. But most don't. Most people convert that audio after it gets back into the studio, back into analog audio. Then they plug it into an analog mixer, and then they mix the audio around, and then they route the analog audio around. Every time you're doing that, of course, you're throwing away quality. Then you process the analog audio, which of course introduces noise and loss of quality. And then you turn it back into ones and zeros as we go back into a computer. And then we send it out over the air, at which point it's probably being bit reduced, or commonly called compressed. And we send it out over the air, and we've lost quality once again. Audio over IP, Rock specifically fixes all of this. So Rock maintains consistent latency. It helps coping with network jitter and packet rendering. It helps with packet loss if the network is unreliable, and it helps converting between the sender and receiver clock domains. So the problem with digital audio that people run into very early on, and we struggle with this right here in the studio, is that you have to have very precise timing when you want to do audio over IP. And the reason that you have to have very precise timing is because if you have two different devices, and one device is encoding audio and one device is receiving audio, and you can't suffer any sort of latency because, for example, my headphones, they are IP. They are receiving audio over IP. And the microphone is sending ones and zeros over IP. And so for me to hear myself in my headphones with no perceivable delay requires a lot of technology to wrap around that. And Rock addresses a lot of this. So we have something very, very specialized in the studio that we're using. It's very, very similar to what Rock is doing, ROC. And there essentially, anytime we talk about network traffic, there are two ways that we can encode network traffic. I always hear people say TCP/IP, TCP/IP. And I think part of that is just we hear it in the movies, and so we like to repeat it. The truth is, you can layer UDP or TCP over it, right? Like, IP is a protocol, you can layer whatever you want on top of it. So it kind of drives me nuts because I incorrectly hear people talk about UDP over IP as TCP/IP. That's neither here nor there. I digress. TCP, every single packet gets an acknowledgement. So when in the case of audio, for example, I send an audio packet, whatever device is receiving it sends an acknowledgement back that says, yep, I got that audio packet, send me another one. We send another one, so on and so forth, right? And there's a lot of communication to ensure that packets get from one device to another, and that's great. The advantage is you never ever lose any audio. 100% of the audio goes from the sender to the receiver. And that's great if you're downloading a podcast. That's fantastic if you're downloading a video. It's amazing if you're moving an audio file from one computer to the other. If you're not doing anything live, that's great because you can afford to take time. If something doesn't get there, just send it again, and then it will get there. And it might take an extra 2 seconds, but who cares, right? That's not the case. It is not great if you're recording a live interview with a talent that's 2,500 miles away. In that case, the process of confirming every single packet, and really I'm abbreviating the TCP process, right? Those network engineers out there that are screaming at me understand there's actually a lot of different messages that are sent and received for the purpose of moving a packet from point A to point B. But for just for being short, I will just say that it introduces latency because we have all these extra steps that the packets have to take. So some of you that are skipping ahead are going, well, UDP must be the answer. Let's send everything over UDP. And interestingly enough, that is the way that a lot of broadcast engineers and a lot of musical people actually do encode audio over IP. We use UDP. In fact, all of the systems that you're probably familiar with and some of which you maybe deal with on a day-to-day basis are using the UDP protocol for audio over IP. The most basic example I can think of, or the most prolific example I can think of, is SIP. Any sort of IP-based phone system uses UDP to send audio. And the way that they're doing that is with a protocol called RTP, or Real-Time Streaming Protocol, RTSP, commonly abbreviated RTP. And so all of our encoders that are actually in the studio, or the remote encoder that I'm on right now as I'm doing the show from a different location, all of these devices are using that RTP protocol, are using essentially RTP over a UDP stream of real-time packet audio. And the reason that we do this is because of latency. When you're doing live audio, if a packet doesn't make it in time, there's really nothing we can do about it from a technical perspective. The audio either gets there or it doesn't. If I'm having a conversation and I say a sentence and one of the packets didn't make it there, there's no way for us to go back in time and insert that audio. We've just lost it. So RTP does what it does best, and it stutters at the last packet. And sometimes you'll hear that, and then it'll continue on, right? And that's just what we live with RTP. The problem is there is no error correction. And so you just kind of have to accept that you've lost audio and move on. And we have all these little workarounds that we try to do. We have things called forward error correction. And essentially what forward error correction is, we send 4 simultaneous RTP streams. Now, the way I'm doing it right now, 2 of them are going over the Wi-Fi and 2 of them are going over a separate LTE WAN card. And as long as one of those 4 streams makes it there, we don't have any loss of audio. So it's very rare that you ever hear audio drop on this program, despite the fact that we're oftentimes in very rural locations. And the reason for that is we have a lot of very sophisticated equipment that makes sure that that happens. But it's really, they're Band-Aids, they're workarounds. They're not actually fixing anything. We're just covering for the fact that we can't actually solve something. The ROC, this project, simplifies that entire process. So the user just writes a stream to one end, and then another user reads it from another end. And ROC in turn performs the encoding and decoding, and more importantly, deals with the problems related to real-time delivery. And so that's what deals with the network jitter, and it deals with packet rendering, and it deals with consistent latency, and it restores lost packets, and it compensates for clock differences between the sender and the receiver, so it makes sure everything is lined up. ROC also provides command line utilities that can be used to read an audio stream from a file or an audio device, or you can use it to transmit over the network and write to a file or an audio device or another computer. So these tools can be used with Bare ALSA, it can be used with Pulse Audio, Core Audio, or a bunch of other audio backends. Now, the interesting thing about Rock, when I was reading into it, and I was fascinated about this, I saw this project come out, and I thought, man, more people need to be doing stuff with audio over IP on Linux. And I really believe that there is a huge future in this. I don't believe in 10 years anybody's going to be connecting analog audio cables except to an analog device like a microphone or a pair of headphones, right? And so I started digging into this. It turns out they actually use RTP, the exact same technology that we're using here in the studio. So it didn't take long before I found a forum post where somebody asked the question, is it AES-67 compliant? Now, if you're not familiar with what AES-67 is, it is a universal standard for encoding audio over IP packets. And in Linux, this affects us pretty heavily because Pulse actually uses RTP to encode packets over IP. And so you can actually ingest those IP encoded packets with a tool that's built right into Pulse into other systems that are AES-67 compatible. And so I was very excited at first. I thought, well, that'd be great if this Rock program sets all of that up and essentially slims it down and simplifies it. Because as a person who has set all of that stuff up in Pulse, let me tell you, it was a massive headache. It was not a simple process to get all of it to work, but it does work. And turns out they are not AES-67 compliant, but it's not because they didn't want to be AES-67 compliant. The guy who is writing this has just not heard of it. So this is my public call to anybody who has any influence in the audio over IP community or in the Rock community. If you know the developer or are involved in that group, please consider adhering to the AES-67 standard, because you become instantly compatible with a bunch of different devices. You become compatible with the music industry flat out. You become compatible with the broadcast industry flat out. And right now, we don't have an elegant solution to get AES-67 audio in Linux. It's a real pain in the tuchus, unless you want to use a proprietary solution. And you can use a proprietary solution. It runs on Linux, but you got to pay money to it, and it requires licensing, which means every time you reinstall the operating system on your laptop, you have to go back and generate a new license and activate and all of that kind of jazz. And so I really hope, as cool as this project is, and they're getting a lot of steam, all positive, which really says something to me about a project, because, man, people on the internet, they're never shy to tell you you're doing something wrong. So if everybody's very positive about a project, it has to really exceed expectations. But I hope they can be convinced to deliver AES-67 compliant audio. Just an absolutely outstanding project. We will have a link for you in the show notes, podcast.asknoahshow.com. Make sure to check it out. The project is called Rock, R-O-C, Rock version 0.1, an absolutely fantastic release. I've played with it a little bit. It seems awesome. Very simple and straightforward to set up. Does not require a lot of tweaking or a lot of tinkering to get it to work. Just very straightforward. And to that end, maybe there are other things that I need to look at more seriously. So 2-Bit in the chat room asks about Jack. And obviously Jack is a very powerful, but again, very cumbersome thing to set up. And I'm sure Jack, being as powerful as it is, almost certainly has the ability to encode and decode packets over IP. But I personally have not had much success using it. In fact, I actually use a cheat. I actually cheat my way around getting Jack set up. Anytime I have to use Jack for anything, I actually install another application on top that actually has its own Jack configuration. Then I use that to make Jack do what I want it to do, and then just run that little application on the side. But it's not a very elegant solution. There's better ones out there, and But there may be other solutions. And if you have a solution, let me know. Email me live@asknoahshow.com. I would love to hear of your solutions on how to fix this or how to get this going. If there's something else I can check out, is specifically if it's AES 67 compliant. And if not, I really, really wish the ROC team the best of luck, because unlike video editors on Linux, this is something we don't have. This is something that is not done, I think, extraordinarily well. I think there's a lot of room for improvement. I think it's a really big need on Linux, and I would love to see it come to fruition. By the way, speaking of things that I personally would like help with, and I don't do this very often, but I'm going to do it tonight. I have a new hobby I'm kind of playing with. I'm digging into astronomy, and I'm having a lot of fun with it, but I am looking for different Linux programs, specifically ones that I can control a telescope. I would like to control a Celestron telescope, and I'm interested if anybody out there has some knowledge, maybe using Stellarium and interfacing that to a telescope. I see that the options are there. I have configured my various COM ports, but the best of my understanding is that you need some sort of intermediary for Stellarium to speak to the control unit for the tripod for the telescope, and then you can actually, from there, then the telescope uses a separate COM port to talk to the control system. And I've kind of managed to sort of piece that together, but I have a feeling, as vast and as knowledgeable as the Ask Noah Show audience is, particularly as it comes to things like space, because, I'd say it's probably like a 98%, if I was to guess, audience metric of people that are also into astronomy. I don't know why it's bitten me late in life, but that's what I've been doing the past few weeks, and trying to integrate Linux into it as much as possible. My end goal, if I can ever get there, is I would like to have a telescope at a remote location that has a great viewing capability, and then have all of that remotely controllable from my house, and have images sent remotely and so on and so forth. Because right now, obviously, city light pollution prevents me from being able to participate in viewing astronomy from where I currently live. And so one of my thoughts is, I bet using Linux, and I bet using things like a Raspberry Pi, an open source software, and leveraging that, there would be a way that I would be able to accomplish that. I've seen a couple places online that you can rent telescope time right in your web browser. So I figure us Linux nerds can probably do it, and we can probably do it with open source. So that's going to be my project over the next couple of months, and if you think that you could help or have any suggestions, I'd love to hear it live at AskNoahShow.com, and who knows, well, it might even make a segment out of it. So, Chris Wright is our guest this hour. Now, Chris is the Vice President and Chief Technology Officer at Red Hat. Chris has spent more than 15 years as a Linux developer, and an absolutely fantastic guy, a pleasure to speak with. He's worked in the telecommunications industry. He's worked on high availability. He's worked in the Linux industry on security and virtualization and networking. The amount of times that I was talking to Chris that he would say something like, "Oh, I worked on that project. Hey, I remember when I did something with that." I mean, it's absolutely fantastic. A really intelligent guy. Had a chance to catch up with him over at Red Hat Summit a few weeks ago, and we managed to record a little segment. Here's that audio. Chris, thanks for taking the time to sit down with us. We appreciate it. Obviously, Red Hat has a vast and wide array of lineup of services and products that you guys are working on: RHEL, OpenStack, Kubernetes, OpenShift, Istio. Give us a rundown and an overview of what these changes have been over the last 10 years.
Well, I think a huge shift over the last 10 years has been around transitioning from a single server to what I would just say distributed systems. So if you go back in time, Linux was the platform. Linux was a platform for applications running on a piece of hardware. Now we started to virtualize that hardware, but initially that was really very similar looking to a server environment. So the application and the operating system inside the VM were maybe lifecycled together, maybe even custom artisan handcrafted snowflakes. And so over time, you saw the cloud come in, create an immutable image, start to separate a little bit of the content, the application content away from the OS. Containers really formalizing that separation between application, runtime dependencies, and the operating system. And all of this is to really improve the speed at which you can build and deploy applications and do it at scale. So to me, what we've done from a Red Hat point of view is think beyond just RHEL. I mean, if you go back in time, I've been at Red Hat a little over 13 years. When I started to help Red Hat become a virtualization company. So At that time, we were just RHEL. we started to add middleware and add hypervisor support, and over time, we've really built up this entire portfolio around scaling applications distributed across multiple different types of deployment footprints, like a public cloud, multiple public clouds, on-premise in your data center, and kind of looking forward even out to the edge, so that our view is hybrid cloud, our product portfolio is supporting that. And to me, it's kind of, well, we're building distributed systems. You need the right tools to build rapidly and deploy rapidly out into that complex environment.
A lot of those tools are found with things like Kubernetes and OpenShift. How do you see that evolving over time?
One of the really cool things about Kubernetes is, if we take it back to Linux single server, Kubernetes distributes Linux. And the reason I think that's important is, number one, look at the success of Linux. It's been around for over a quarter century. Why is it still going? Like, what's happening there that's unique, that keeps it fundamentally a huge part of our entire industry? I think it's about the vast number of different types of workloads that run on top, and the crazy array of hardware that it supports underneath. So it's created this abstraction. It's evolved with all of the different changes in hardware as well as application needs. And that's for, again, predominantly like a single server. Kubernetes distributing Linux out to broad scale gives a new kind of platform target. But the important thing to me is it's an industry-wide platform target. And what's, I think, unique about this is it gives that same kind of longevity into the project, where the whole industry starts to rally around that. It's the independent software vendors, it's other open source projects, it's just everybody thinking in terms of, okay, we're going to containerize and we're going to distribute. And that's a really powerful way for the whole industry to collaborate.
When I started my IT career, I was working with clients to implement thin client solutions. So the idea was that we had central power, and then we had these basically dumb boxes that connected back to a central power station. Mm-hmm. My career progressed to the point that we started to see that power localize into the individual user's desktops. And then we had a period of time where everything was running on a desktop. Interestingly enough, just in the past few years, what I have seen is clients coming to me and saying, hey, I want to utilize and take advantage of virtual technology so essentially we can divvy up these computers because they're so powerful that no one person actually needs a whole computer. And then now we're seeing people actually use dumb clients to establish remote sessions back into a virtual host. I'm curious what you see the evolution of that is. Are we going to get back to a point where we have centralized computing and essentially the end terminal is just kind of a dumb thing that talks to something as a service?
So it's important to look at history, right? And it's easy to take a snapshot and then assume, a certain trajectory. History says, okay, computing's it's decades. And you look back at a mainframe and a remote like VT100 terminal, and I guess you could call that a thin terminal. Yeah. Pretty thin. And then, we evolve, we get client server, the clients get fatter and fatter, and then a round of, okay, we're going to do thin clients and put all the intelligence on the server, and then meanwhile the client computing side gets richer and richer, and okay, we'll fatten up the application. So I think it's just this kind of continuous cycle, and I think that we'll keep seeing shifts. And right now, we've been moving functionality out of the application onto the server side, right. And I'd say that's largely driven by phones, like not necessarily that they're low power, because by those kind of mainframe days, it's a supercomputer in your pocket. But the simplicity of the interface, the kind of keeping the apps really clean, that's been driving some of the thinking. And but then you start pushing more and more JavaScript to the phone or to the client side. What I think will happen is power consumption on your device will really matter. Mm-hmm. As apps get more and more complicated, they become more power hungry. As you have more compute moving to the edge, you have a place to offload functionality from your phone to a low latency connection, one hop in the network. So I think we're just going to keep seeing this sort of ebb and flow of hardware architectures and software patterns and use cases moving between how much do we put on the client and how much do we put into the server, where the server may not be always centralized, it could be distributed at the edge.
Do you see the internet becoming so ubiquitous, having anything that plays into that as well? The fact that we have internet basically everywhere we go, Wi-Fi is everywhere we go, and so before we almost had to have localized computing environments, because if you were going to edit a document or write an email, you might have to do that locally and then send it out once you get connectivity. Obviously that has changed. Does that play into this?
Without a doubt. I mean, there's an expectation for total connectivity. Now, it's important to remember that the whole globe isn't covered. So we still have this digital divide, and it's a really important socioeconomic thing to consider about how we evolve as humans on this planet. But that ubiquitous connectivity, I mean, again, go back to the phone, you just expect that you're always connected, whether it's on Wi-Fi or whether it's through your cellular service provider. And with 5G, I think we'll see just that continue to grow. I mean, this expectation that you can have high bandwidth, low latency connections always is important. The connectivity consistency isn't always the same, depending on whether you're cabled or whether you're going, if you're mobile. And so the need to have applications that can have some level of functionality without being connected, I don't think goes away. And when we look at some forms of edge computing, there's actually an assumption, like take a store, for example, there's an assumption that the store needs to, if you're pushing some functionality out of your data center into the store, you probably are in part assuming that the store may not always be connected. So if you had some crazy system where you couldn't open your doors because you lost your connection to your data center, sure, that would be no good. Right. So I think we're going to have more and more expectations around connectivity, but we'll still have systems that pay attention to functioning when they're not fully connected all the time.
As security becomes more and more of a focus for businesses, do you see something like Linux vServer becoming a focus for RHEL?
Interesting. I used to work on Linux vServer a long, long time ago. So I would say security, super important for Red Hat, for our customer base. vServer as a way to do an implementation, I would put that closer to a type of isolation that we do today with containers. So containers are important. The way we build containers is, one, there's a couple of kernel primitives that allow you to isolate namespaces and manage resources associated with that isolated namespace. That's the core of a container. What we do at Red Hat is we wrap a mandatory access control policy around that container to really improve the security stance of what's running in the container versus the host. So we'll continue to do work like that. Super critical that we have the right kind of security risk profile for our customer base. The technical details, is it vServer? Probably not. It's probably really just containers augmented with mandatory access controls and even filters, syscall filters like seccomp, so you can limit the number of syscalls that a single container could make down to the host level. And then there's probably opportunities to get connected to underlying hardware isolation mechanisms. We did that 100% for virtualization. There's a couple of attempts at that, and the combination of virtualization and containerization, they're still a little heavyweight, so I think there's some opportunity there that we haven't quite tapped into yet.
AI is a very disruptive technology, and we're seeing it becoming very ubiquitous and very prolific. What is Red Hat doing to position itself to provide the best experience for its customers?
It's a huge workload. We see it across all of our customer base. What we're trying to acknowledge for ourselves is, number one, we're not here to write the next most amazing AI framework. It's not our core competency. However, all of these frameworks are being written in open source communities. And so we pay a lot of attention to the different projects that are associated with machine learning. Our focus is onboarding those onto our platform and then ensuring that they get kick-ass performance. And you look at hardware accelerators, well, what's in charge of hardware? An operating system. So we focus on the hardware enablement and then making that hardware accelerated runtime environment accessible to a virtual machine with OpenStack, a container with OpenShift, so that applications, machine learning, model training applications, can take advantage of that accelerated runtime. And then we work with a partner ecosystem that have more specialized expertise in specific models or some of the frameworks so that we can really support our customer requirements, which are, they've got a lot of data. They want to stream that data in, do training, model training, build models, deploy models for inference, connect those inference engines to applications so that applications are smart. They're contextualized, they're personalized, they're giving good recommendations to the end user. So our view is we're a platform company, and we want to support those workloads, and we want to make sure they run with great hardware optimization.
Is there a point where you see Red Hat developing their own unikernel module?
It's a great question. Now, one question is, what's the use case? So we got to understand what problem are we trying to solve. So unikernels tend to be a mechanism for accelerating applications when you're running them in, say, a virtualized environment, or maybe even in a serverless context. So far, we haven't seen a huge amount of commercialization of unikernels. And if you look at some of the different projects out there, they are not always derived from Linux. In many cases, they're custom-built unikernels. What we've been looking at is how could you take Linux and turn it into a unikernel? And so we've done some work with some researchers actually here in Boston, at Boston University, where with literally about 10 lines of code added and about 20 lines of code modified in the Linux kernel, and then 1 line of code per system call in glibc, we've been able to make a new environment where you can compile the kernel, glibc, and your application together as one static binary. And the reason we think that's so important is if unikernels are going to be a thing or not, if they're not built from Linux, you're going to really struggle to maintain that velocity of feature functionality and kind of application compatibility.
Absolutely.
So this is what we're looking at. And again, we have to understand the commercial motivations and what does it really look like from a customer point of view. But we're doing the technology exploration right now to figure it out, and it's turning out to be really cool. Even a lot of work, but in the end, relatively unintrusive in these core projects, glibc and the kernel. And probably an important open question is, how do you debug such a system? So I think we're so used to an operating system and an environment where even though we recommend against it inside your container, people still want to SSH in and go see what's going on.
Sure.
And you're not going to be able to do that in a unikernel unless you have some crazy KSSH kernel module that's compiled in there, and that just doesn't really even make sense. So how do you get the instrumentation, visibility into the application, debugability so it's usable, plus all the acceleration, performance gains that you'd get? So we're focusing right now performance. We got to look at usability and then understand the commercial viability. So long-winded way of saying we're looking at it. We don't know where it's going.
Makes perfect sense. With the push for virtualization and companies wanting to do that to get a better bang for their buck out of their physical hardware, are you seeing anybody push back on that and saying, I'm not willing to retool my infrastructure to move from a physical server to a virtual machine, or is that not really an issue?
Well, that's an interesting question right now. So if you'd asked me that very same question even just a year ago, I would have said, no, everybody's all in on virtualization. What we've seen in the last year, maybe a little longer, Kubernetes has really taken off. It's completely won the container orchestration platform. Some of our customers are starting to say, why run that in VMs? Why not just run it on bare metal? It's got Linux. Linux runs on bare metal. It's been running on bare metal for decades. So we've actually been investing in that. And here at the Red Hat Summit this week, we announced a product that's around this technology we call KNI, Kubernetes Native Infrastructure. So we're looking at deploying Kubernetes to bare metal. You get the same consolidation capabilities or benefits of virtualization. And in fact, we're working on a project, an open source project called KubeVirt, which brings virtualization support on top of Kubernetes. So now you could run a single orchestrator spread across a number of hosts, managing containers and virtual machines, all as peer citizens on the same platform.
Wow.
Which is pretty cool. Where that goes and exactly how that gets, what kind of enthusiasm develops around that, that'll remain to be seen. But yes, I think it's not resistance to virtualization, but it's now saying, well, if I'm going to deploy a container platform, do I have an opportunity to take a layer out of the stack and really just run containers in bare metal, and then maybe even somewhere down the road, I have a way to onboard some virtual machines into that same orchestrated distributed platform.
So from your perspective, personal opinion, is this a function of just lowering overhead? I don't have to manage updates for 5 systems. Now I just have the one central physical machine to update, and I still get process isolation. I still have security. I still have modularity. Is that the benefit there?
Yeah, I think that's really it. It's about simplifying. If you think about what we're doing today, we're building more and more complex systems. So while we're doing that, we have to look at any opportunity to take complexity out of the system. Certainly with complexity, we're adding automation so we can manage complexity, especially at scale. But hey, if we have an opportunity to reduce some layers, it's definitely worth looking into. And there's, the different question would be, are there performance optimizations that you gain, or performance improvements that you gain by removing a layer? Certainly, virtualization adds some overhead in the I/O path. So if you're running a container workload in a VM and you move that to run directly on the bare metal, you're going to remove some of the virtualization overhead for the I/O. Compute-bound tasks, it's really not an issue. So I think there's some questions around, is there a performance benefit? And certainly anything you can do to simplify complexity, good thing for operations.
Absolutely. Make it more modular and give more control back to the individual user. I love it. What has brought everybody together this week is open source, right? It's not a tagline. It's not a brochure filler. It's what everybody I've talked to at Red Hat seems to hold as a core belief. To you personally, what does open source mean?
Well, first of all, open source has really given me my livelihood, so I have to be really thankful. But open source means a handful of things, really specifically. It means it's a development model. It's an engineering practice. It's a way to build software. It's a way to interact with a broader community. To me, an open source community is, number one, a place where collaboration happens. It's collaboration around a shared vision. So you've got this idea, you want to work on it together. It's collaborating around a shared vision with people. And what's important about that is we're developing human trust relationships to actually get work done. It's not about like some legally binding this or that. It's totally about people and how we relate with one another. It rewards people who take initiative. So all you have to do is show up and do something.
It's empowering.
It's totally empowering. And that's what got me involved. Like way back in the beginning, I showed up, I did something. Hey, they even accepted my patch. Like, what a rush that was. And let's dig into that. Let's dig into that a little bit. So everybody has, and I know I did, right? I started out in proprietary technology. I came over to the open source side because I had an aha moment. I had a light bulb, and I hit a brick wall. I couldn't install Windows one more time. I couldn't install drivers or deal with the blue screen one more time. And so I looked over to open source and the way that they were approaching problems and the way that they were dealing technology and the way that they were putting the power back into the hands of the user rather than a corporate interests. What was the aha moment for you? What point did you go, that's what I want to spend my life doing, is promoting this way of developing software? It was, to put a relatively fine point on it, probably about 20 years ago. And I was working in a project. I was actually responsible for the high availability of a platform for the company I was working for. And this responsibility was actually a little frustrating because it ping-ponged about once a quarter between go build something and go buy something. And I was kind of going crazy. And along the way, I found this project in open source that was doing high availability. And I got involved, and I found that, number one, the people that I was communicating with were just brilliant. And I was relatively new to this space, so I had an opportunity to talk to the smartest people on the planet around this fascinating topic to me. Not only did I have that opportunity, but they took the time, like they cared, and they shared their experience with me. And ultimately, I was able to get involved and submit a patch. And it was submitting the patch and having that patch accepted and that whole process of engaging with this amazing community that was the aha moment. And like I was hooked, and kind of coincidentally in time, my roommate brought home the GNU Manifesto. I realized there's more of a social political movement involved with open source beyond just the technical capabilities of building software together collaboratively. So I was totally hooked at that point, and I'm still hooked. I love it.
Me too. Chris, thanks so much for taking the time to chat with us. We really appreciate your time. We'll get you back in the program soon.
All right. Thank you.
Again, open phones this hour, 855-450-NOAH. That's 855-450-6624. The email, live@asknoahshow.com. I did see a caller jump in there and jump out real quick, so maybe he or she is short on time, but I got a couple minutes left in the hour. If you want to give me a call back, we'll take it right away. There is an interesting article, and we don't have time to dig into it, and probably with the entirety that it deserves, but it will be linked for you in the show notes, podcast.asknoahshow.com. And the title is, Why Open Source Firmware is Important for Security. Now, that might seem pretty obvious to you, but the author does a very, very good job of ranking security in stages or in rings as privilege levels. And what the author points out is that the highest level of access, the highest level that we ever award access to, has to be given to the hardware level, and that only comes with firmware. Interestingly enough, you see the exact opposite from a push from open source. And I myself am very guilty of this. I have probably said it on this program. I know I've said it on many others. I'm not as concerned as what the software license of the code is. I'm more concerned if it runs on Linux. Once we get everything running on Linux, then I'll go back and be worried about the software license. Now, anything I pay to develop, anything we develop at Altispeed Technology, certainly anything that Ask Noah funds is going to be open source because I believe that people should open source their code. But if there is a piece of software that fundamentally solves a problem for me on Linux, even if it's a proprietary piece of software, I'm probably still going to run it on Linux. And my rationale for that has always been something along the lines of, well, I care a lot about the operating system and how it accesses the hardware and how it deals with the hardware and the stability and security that comes with that. If one application, if I don't have access to its source code, I'll just kill that application or I'll not run it. The author does a very good job of convincing me that really, if that's your approach, then you should never make a compromise when it comes to firmware. And interestingly enough, that's the one thing that Linux users are the least vocal about is open source firmware. Many of us, myself, and I include myself in this definition, tend to lump people that are concerned about things like open source firmware in with the Richard Stallmans of the world. Not that that's a bad thing, but I don't see a huge push on this. And so the author divides it into user space, kernel, hypervisor, system management mode, or SSM, the UEFI kernel, and management engine. And so the TLDR is the goal of the root of trust should always be to verify that the software is installed in every component of the hardware is the software that was intended. And this way we can basically know without a doubt and verify that the hardware has been hacked. And since we have very little insight and very little visibility into the code that runs on a lot of these devices, it's very difficult, if not impossible, to determine. And so how do we really know if firmware in a component is vulnerable or that it doesn't have any backdoors? And the answer to that, of course, is we can't. We can't know unless the entire stack, top to bottom, was open source, which oftentimes it's not. So that's my call, I guess for the third time in this episode, my call for action, as it were, to go out and see if you can become more vocal about open source firmware. At least give the article a read. Again, it'll be linked in the show notes. Check it out and see what you think. But I think it's a very excellent outlined article, and basically it changed my mind on something. So figured we'd share it with you as well. Feedback can be sent to live@asknoahshow.com. We take it at the end of every program. Listener writes in and says, "Hi, Noah, longtime listener and a big fan. I just ordered a T480, which I plan to try running Linux as my desktop OS. I've created my first open source project, and I'd love to share it with anybody who finds it useful. It's called MacMon. It's called MacMon because it monitors all of the MAC addresses on your network. The program scans your network and keeps a list of everything it discovers, along with some info about each device. It has a browser interface that you can label devices and keep notes. You can add an email, so anytime a new device is detected on your network, you are notified. Then you can whitelist devices, run port scans against them, or even click a button to use ARP spoofing to block it from other network resources. The point of this program is to generate and maintain a network inventory while being notified of all rogue devices. Got to keep the pesky neighbor hackers off your network. And closed circuit to city of Baltimore. You might want to check this out. This program runs on a Docker container and can be tested on a Raspberry Pi and x86 Ubuntu, but should pretty much run on anything. If you have Docker installed already, it's a single line to get it up and running. Below are the GitHub and Docker Hub links. I hope you or else anywhere out there that can find some small value in this program. Thanks again for all the hard work and dedication to the community." Then he gives a link, hub.docker.com/r/macmondev/macmon. We'll, of course, have a link for you in the show notes. You can find those at podcast.asknoahshow.com. And a huge thanks to Kevin for writing in and sharing this program. This is absolutely fantastic. Now, obviously, those of us that work in InfoSec, we wouldn't rely on MAC addresses for our sole security, because obviously MAC addresses are pretty easy to spoof. But that's a great extra tool to have running. And again, if you have any concerns about the security, well, guess what? You can just go audit the code and look at it. And we'd invite you to join us in our interactive chat room. You can become a part of the program every week by going on Freenode and joining Ask Noah Show. We're going to probably have some giveaways coming up in the next couple of episodes. So if you'd like to be a part of those, make sure you're in our interactive chat room. And we're looking at expanding that quite a bit. We talked about this at the beginning of the year, maybe the end of last year. I can't remember. But we talked about having essentially a bouncer available to those that faithfully show up for the Ask Noah program. Of course, you wouldn't have to just use it in our chat room. You can use it for any IRC chat room. But we think that IRC is a great place to kind of come together and hang out, and we would like to turn that into a hangout that exists outside of the show. So make sure to join that interactive chat room. Again, you can go to freenode.net, Ask Noah Show. There's a couple other ways to get to it, actually. You can also go to asknoahshow.com. We've got a built-in chat client on the website. I believe it's chat.asknoahshow.com, I'm being told. And if you go to ultispeed.com, we also have one that's built right into a web browser, so you can do it that way. The Ask Noah Show continues next Tuesday at 6 p.m. Central. Huge thanks to Ben, our producer, Sarah Alcross-Scritter. We'll see you next Tuesday at 6 p.m. Central at asknoahshow.com.